That's not me. So I'm going to talk a little bit about our how we ended our water year, and then I'm going to go into El Nino, and then I'm going to provide our winter outlook. So our water year, we calculate our water year starting September 1st, October 1st, and it goes until September 30th of the following year. So we just ended our water year at the end of September, and this is how it panned out. So this is the percent of normal, and you can see that across the Palouse, across much of eastern Washington and North Idaho, we ended up slightly below average for this time of the year. The Pullman Airport had 16.32 inches, and average, the 30-year average, is 17.53, which is about 93% of normal. So, I'm sure you've heard of this word. It is El Nino, and it has returned. We are currently in an El Nino right now. However, El Nino typically does not have big impacts for spring, summer, or fall. El Nino and La Nina, or what else is known as the Southern Oscillation, that their impacts are bigger during the winter months across the United States. And what that means for us in the Pacific Northwest is we typically see warmer than average temperatures across the region. So, there is a 100% chance of El Nino. We're in it right now. It will continue. The question is it going to be strong or as historically strong? So, there's an 80% chance of El Nino continuing through the spring months, and then there's an 80% chance that it will be a strong El Nino event. And then there's a 30% chance of a historically strong El Nino, and that is comparing it to the events of 2015, 2016 winter, as well as the 1997 and 1998 winters. So to kind of show you, this is kind of hard to see, but this is Mexico and South and Central America, and here's South America, and this is the equatorial region. And that's what they're looking at to define El Nino or La Nina, the Southern Oscillation. So the Southern Oscillation is calculated in these Nino regions. There's Nino 1 and 2 down here, and then there's Nino 3, 3.4, and 4. And what we look at is the sea surface temperatures in the Nino 3.4 region. And as you can see, that is currently 1.6 degrees warmer than it normally is this time of the year. Hence us being in a strong El Nino right now, because those temperatures have been like that for quite some time. So I'm going to talk a little bit about October and November. I realize October is almost over, but there have been 8, I left my notes at the table, but there have been 8 strong El Ninos since we've been watching the Southern Oscillations since 1950s, when we started keeping track of El Nino, La Nina neutral conditions. And 5 of those strong El Ninos have been since the 80s. So we took the 3 previous strong El Ninos and we didn't look at them because of climate change and how things have changed over the last 30 years compared to what happened 50 to 70 years ago. So we're just looking at the last 5 strong El Ninos. And you can see that this is the composite of that. So that's all 5 El Ninos put together. What was their temperature anomaly, or how much warmer than normal or how much cooler than normal are they normally? And you can kind of see how it spreads out through the years. So this is 82, 91, and you can see, so these are all the divisions, all these little, they're not county lines or anything, they're climate divisions. And the Palouse of Washington falls in Climate Division 10. And so you can see that in 82, the temperatures were cooler. but in 91, they were near average. And you can see how it kind of varies, and you can see in 2015 it was very warm across a lot of the United States. But if you were to compile all those together, this is what you get here in this composite event. And it's showing you slightly below average temperatures for October and November. Now, as we move on to precipitation, it is definitely a more mixed bag across the region. Again, this is the composite. So the composite shows just right around average across the Palouse climate districts. And, back. But you can see from year to year, it does kind of vary a little bit from near average to maybe in 2015, slightly below average precipitation for those months. So October's been warm until basically yesterday. So we're gonna go with October will probably play out, even if we stay cool through the 31st, October probably will come out slightly above average temperatures across the area. As far as precipitation goes, I think it was a pretty dry month up until, it's been a pretty dry month. So I think it's probably gonna end pretty dry as well. So as we look towards November, the Climate Prediction Center does monthly outlooks. They put this one out last week. Every third Thursday of the month, they put out an outlook. And so they'll put another November outlook out on October 31st as well. And you can see that they're saying there is greater, I'm sorry, I don't have my glasses on. It is greater than a 40% chance of above average temperatures for November. And it doesn't show a clear signal one way or the other for precipitation. So there's equal chances of below average or above average precipitation. So now getting into winter. So if we look at those 5 previous strong El Niños, here's what the composites are showing. And you can see there is a clear signature of above average temperatures for much of the northern US. And the precipitation is a little bit more of a mixed bag for eastern Washington, North Idaho. You can see from the Cascade Crest into northeast Washington, it's showing above average precipitation signals. But as you get into climate region 10, which is the Palouse, it shows below average, slightly below average precipitation. So let's dig a little bit more into that. So this, I know this is kind of a difficult map to see. I couldn't put in the counties, but 69 is Pullman and 68 is Moscow. That 72 is Spokane. There's Rosalia and St. John and La Crosse in there too. So this is, during an El Nino, this is what the percent of normal snowfall is for those locations. Now that's any El Nino. So El Nino can be weak, El Nino can be moderate, El Nino can be strong. So this is taking all of those El Ninos and saying, on average, when we have an El Nino, that's how much percent of normal snowfall we will see. So you can see that we typically see less than normal snowfall across the Palouse. So I dug in these graphs right here. We have what is called cooperative observers. They are fantastic. They volunteer and they send us daily their data. They have a little weather station at their house or place of business, or in Moscow, it's at the University of Idaho. And they send us daily data. And so these graphs here are from those cooperative observers. And that is, I believe my climate focal point was not working today, so I couldn't ask him. But I'm pretty sure these numbers are based off of data since 1950, because that's when we started looking at El Nino and La Nina. So the numbers, that's why the average here for Pullman is a little bit different than here. So, but you can see I pulled up the data, and this Pullman data that I grabbed is for our cooperative observer in Pullman, which is 2 miles northwest of Pullman. And so you can